Hello, I'm Dr. Millicent Thomas. In this video, I would like to explain about a normal distribution using a standard normal table. The normal curve always looks like this. It is a bell-shaped curve and it is a symmetrical curve. The mean, median, mode coincides at the center. How it is distributed is depending on the shape of the curve. So the normal curve is always represented by n mu sigma, where mu is the mean and sigma is the standard deviation. Now, when x is a normal curve with mean, mu and standard deviation sigma, we know that all normal distributions are the same if we measure that in units of size, sigma about the mean, mu as center. Changing the units is called standardizing, and the standardized value is also called the z-score value, which is z equals x minus mu by sigma. So this is the formula to find the z-score, or if you would like to standardize this, we need this formula z equals x minus mu by sigma. Once when we use this z-score, the converted standardized normal variable will have a normal distribution with mean 0 and standard deviation 1. And for this normal curve, we can use the table which is called the standard normal table. This table has got values from negative 3.49 to positive 3.49. We know that the maximum value 99.7% of the data lies between negative 3 sigma to positive 3 sigma. So if it is standardized, the maximum value 99.7 lies between negative 3 and positive 3. Now this table gives even other in-between values. So it is from negative 3.49 to positive 3.49 are there. Now in order to understand the usage of this table, let us take this example. The example talks about the scores of an exam which is normally distributed with mean 62 and standard deviation 8. If we are interested in finding the percentage of scores which are less than 53, at least 85, and between 71 and 85, we have to treat this as a normal curve with mean 62, standard deviation 8, and the z-score is x minus mu by sigma, which will be x minus 62 by 8. So for the first question, when it is less than 53, our x value is 53, and hence the z-score will be negative 1.13. Let's take this table. The first page, we have all negative values, and the second part of it, we have all positive values of the z-score. Now, when we are interested in finding negative 1.13, search for negative 1.1, and on the other side vertically it is 0.03. So where it means the value will be 0.1292. So the answer for the probability of z less than negative 1.13 is 0.1292. So this table always gives the cumulative values, that is the area lying to the left of it. That's why that shaded region is given, that red shaded, orange shaded region is given. So we get only those values using the table. So our x is normal with mean 62, standard deviation 8. We are looking for the percentage of score less than 53. X less than 53 is the same as z less than negative 1.13. Here we are taking the z-score to correction to 2 decimal places because we can make use of only 2 decimal places in your z table. So I have converted that as negative 1.13. Probability of z less than negative 1.13 using the table, we got that as 0.1292, and since it is a percentage, it is written as percentage 12.92%. If you are trying to find the percentage for at least 83, we are looking for x greater than or equal to 83, which is the same as x strictly greater than 83. Whether it is strictly greater than 83 or greater than or equal to 83 doesn't matter. The reason, probability of x exactly equal to 83 is always 0. So you can find the z value for that corresponding to 83. 83 minus 62 by 8 will be 2.625. So using a table, you can only find the values less than 2.625 because you always find only the area to the left, which is 0.9957, but you are looking for area to the right of it. So it is 1 minus, which will be 0.0043 or 0.43%. And the last question C is you are trying to find the percentage between 71 and 85. So you have to look for the z-score when x is 71, which is 1.125, and the z-score is 2.82875 when x is 85. Since we have to convert the z-score to two decimal places, we can take that as 1.13 and 2.87. So for 1.13, the area lying to the left of 1.13 is 0.8708. The area lying to the left of 2.88 is 0.9980. So the difference between those two will be the area in between this, which is 12.72%. So in this video, we talked about the normal distribution. We found out the probabilities for a normal distribution using the standard normal table. Hope this video was helpful. Thank you for watching.